Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Geometry Problems with Algebraic Expressions. Alright, reminder, area of the shaded region equals the area of the total or complete shape minus the area of the unshaded region, possibly multiple unshaded regions. For example, problem number 1. A garden consists of a rectangular sitting region surrounded by a flower border that's 3 feet wide. The dimensions of the sitting region are shown in the diagram below. Okay, so if you're following along, we have this sitting region here, which is white, and we have this light gray place that goes around, which is the flower border. And we can see that it is 3 feet wide. And what that means is 3 feet wide here, 3 feet wide here, 3 feet wide over here, 3 feet wide up and down there as well. So it's 3 feet wide the entire way around, just not diagonally. With that in mind, we can find what we need to find to get the total area, the area of the complete shape, and then the area of the the unshaded region that we will eventually subtract by. Now, first things first. Before we start doing length times widths, we need to get the total length and the total width. You're like, Underkoffler, what do you mean? Well, the length from here to here is 3x minus 1, but that's not the total length of the rectangle. The total length would also add the length here. Oh, that's 3 feet. And also the length here. Oh, that would also be another 3 feet. Well, do this with me. 3 plus 3 is 6. Now we're going to add that to the 3x minus 1. Oh, do you see what I did? I made subtraction become adding the opposite. Now I can add my like terms together. 6 and negative 1 makes 5. And the total length, that's why I drew these arrows here like this, the total length is 3x plus 5. Now, I'm going to do the same thing for the total width. The width from here to here is 7, but I also need this width. Oh, that would be the 3. And I also need the width down here. Oh, that would be another 3. So 3 plus 3 is 6, and 6 plus 7 is 13 feet. I hope you're writing this down along with me. Now we have the total length, 3x plus 5, and the total width, 13. Now we can start doing length times width for the complete shape, and then length times width for this unshaded region, which is the sitting region, if you read the problem. Let's do it now. Total length was the 3x plus 5. Total width was the 13. We are going to multiply those together to get the area of the complete shape. Now, this is going to require the distributive property. Now, by the way, I hope you're writing all this down with me. You got headings here, complete shape, sitting region. We are doing 3x plus 5 times 13, and we're going to use the distributive property. 13 times 3x, 39x. 13 times 5, use the calculator if you have to, 65. Now, we need to do the length times width for the sitting region. So the length of the sitting region was the 3x minus 1, and the width for the sitting region was the 7. So we're going to multiply them together. Let's do it now. Distributive property, 7 times 3x, 21x. 7 times 1, oh, bring down the minus. 7 times 1 is 7. Okay, I hope you're writing all this down with me. Now we can finally minus the area of the complete shape by the area of the unshaded region. So let's do this together. Subtract. Oh, are you remembering? You must use parentheses when you subtract by a linear expression. Having said that, parentheses on the left, they honestly don't really matter because there's no multiplier sitting outside. But the parentheses on the right do matter because there's subtraction to the left of it. We are going to make subtraction become adding the additive inverse of this entire expression. Remember how to do that? You change each part. So instead of 21x, it's negative 21x. Instead of minus 7, it's adding by 7. That's how you make it the additive inverse. And subtraction is the same as adding by the additive inverse. From here, you can line up these two linear expressions on top of each other if you like doing it that way, or you can use the commutative property, which is what I'm going to do right here. Either way, we want to add our x's with our x's and our constant with our constant. Numbers with no variables, I mean. All right, 39x, negative 21x, subtract in your head, 18x. 65 and 7 is obviously 72. And that is the area of the shaded region. Now, it's officially the area of the flower border. That's what this shaded region was, 3 feet wide the entire way around. That is our algebraic expression in simplest form. Part A, done. Part B, write Part A's answer in factored form. You're like, factored form? That's where you find the GCF of the two terms, pull it out, factor it out, use parentheses, and then do the distributive property in reverse. Now, how do I do that? Start with the smaller of the two numbers, which is the 18. The biggest factor of 18 is 18, because 1 times 18 is 18. Check right now in a calculator. Is 18 a factor of 72? How do you check that? Take 72 divided by 18. If you get a whole number, then 18 is a factor of 72, and therefore the greatest common factor. If you don't get a whole number, then 18 is not a factor of 72. Did you do it yet? 72 divided by 18 gave you 4. Now, that doesn't mean 4 is the GCF. No. It means 18, the number you just checked, that we already knew was a factor of 18. We just checked it's a factor of 72. So it's the greatest common factor. So write this with me. 18 is the GCF. We make that the multiplier sitting outside of the parentheses. Draw your parentheses. Keep addition inside. 18 times what would make the original 18x? Well, that'd be the x. 18 times what would make 72? If you don't know, take 72, divide it by 18, and you'll get that. Wait, didn't we just do this? Well, that's right. We did, and we got 4. So there you go. 18 times 4 would make 72. And that's the factored form of the answer. Okay, problem number 2. A rectangular swimming pool is surrounded on all sides by a 5-foot wide walkway. And you can see that here on the diagram. Now, we are going to do the same thing here. We're going to get the area of the walkway. But before you do that, you need to find the total length and the total width. Remember, we just did this on problem number 1. So, hit pause on the video. I want you to figure out the total length and the total width. Now, don't do all the work for part A. Just get the total length and the total width. Then hit play to make sure you got those right. Okay, did you get to the total length? Did you get the total width? The length across of the unshaded part is just 15. But this length here is 5, and then it's going to be 5 across over here as well. So 5 and 5 gets added to 15. 5 and 5 is 10. And 10 plus 15 gives you a total length of 25 feet. Did you write that down? Did you use the arrows to show that it's the entire length across? Great. Now, what about the entire width going up and down? Well, the width of the unshaded part from here to here is 4x minus 3. But we also got the 5 feet here, and we'd also have 5 feet up here. So 5 and 5 is 10. And then 10 and, did you make subtraction become adding the opposite? So 4x plus the negative 3. 10 and negative 3 is going to give you 7. 4x plus 7. Don't lose the 4x part. And that is your total width. So total width, 4x plus 7. Total length, 25. Now that we have those, now we can start doing the area of the complete shape and the area of the pool. Remember how to do this? For the complete shape, we need the total width and the total length. Okay, we just got these. 4x plus 7, 25. We're going to multiply that total length and that total width together. Length times width gives you area. So that's for the complete shape. Then you're going to do it for the unshaded part, which total length was 15. Or sorry, not total length. Length of the unshaded part was 15. Width of the unshaded part is 4x minus 3. So we're going to multiply those together. Okay, hit pause and do the distributive property on both of these. Then hit play. Make sure you got it right. Okay, distributive property. 25 times 4x is 100x. 25 times 7 is 175. You probably didn't even need a calculator for that. Multiplying by 25s is like quarters. 15 times 4x is 60x. 15 times 3 is 45. So there's the distributive property for both. From here, to get the area of this shaded region, which is the walkway going around the pool, we are going to have to subtract. Okay, the parentheses on the left really don't matter, but the ones on the right do. I want you to hit pause right now, and I want you to make this adding by the additive inverse. Hit pause. Do that part right now. Okay, did you already make it the additive inverse? Instead of 60x, negative 60x. Instead of minus 45, adding 45. Good. Finish the rest on your own. Hit pause real quick. Add your like terms. Okay, did you already add the like terms? 100x, negative 60x gives you 40x. 175, 45 gives you 220. Part B. Write this answer in factored form. I would like for you to try to find the GCF on your own. Hit pause, find the GCF. Okay, did you already find the GCF? Start with the smaller number, 40. The biggest factor of 40 is 40. Is 40 a factor of 220? One way to find out, take 220 divided by 40 and, oh, no, gave you a decimal, so no good. What's the next biggest factor of 40? Well, 2 times 20 makes 40. Is 20 a factor of 220? Check in a calculator. Well, actually, you should just be able to look at it. It should go 11 times. If you don't believe me, take 220 divided by 20, you will get 11. So what does that mean? Boom. 20 is the GCF. Write this down. And then hit pause. Figure out 20 times what makes 40x and 20 times what makes 220. Hit pause. Figure that out. Did you already do this? 20 times 2x makes 40x. 20 times 11 will make 220. Okay, no more Underkoffler guiding you. You're going to do number 3 completely on your own. And when you're done with 3, you might as well do number 4 as well. Number 4 is a triangle problem with perimeter. We've had those before. It's a little bit more complex because there are some parentheses. You're going to have to do some distributive property. But aside from that, I believe you should be able to do number 4 on your own. So hit pause now, take your time, do 3 and 4, then hit play when you're ready to see how you did. Okay. Did you already do 3 and 4? If not, you better hit pause now. Okay. Total length. 4 and 4 over here added to 5x plus 2 will give you 5x plus 10 because 4 and 4 makes 8. 8 and 2 makes 10. 4 up here, 4 down here, and 20 going here. 4 and 4 is 8 plus 20, 28. Now that we have those dimensions, we can take 5x plus 10 multiplied by 28. We can take 5x plus 2 multiplied by 20. Distributive property. 140x, 280. Over here, 100x and 40. Subtract. Now, I hope you guys know with the video. If you need to fix anything, you can always hit pause, fix whatever you got to fix. First expression stays the same. We're going to make this adding by the additive inverse. Instead of 100x, it's negative 100x. Instead of plus 40, it's going to be minus 40. Now, before I go any further, I should make the subtraction become adding the opposite. From here, I can now line up my like terms or just use the commutative property. 140x negative 100x is 40x. 280 and negative 40 is 240. Have you already done part B? If not, you better hit pause. Okay, the greatest factor of 40 is 40. Is that a factor of 240? Why, yes it is. 40 is the GCF. 40 times x would make the original 40x. 40 times 6 would make the 240. And there's your factored form. All right, problem number 4. If you have not done number 4 yet, you really need to hit pause now. Perimeter is just finding the distance around the shape by adding all these things together. However, there is some distributive property to be done. So if you haven't done that yet, or if you realize you messed up, hit pause, do what you got to do, part A and part B. Do them on your own, then hit play when you're ready to see how you did. Okay, did you already do part A and B on your own? Let's see how you did. For triangle 1, we're going to take the first side plus the 5x plus the 18. Triangle 2, we're going to take the side with parentheses plus the 8x plus the 14, adding the three sides together. Now, distributive property. 4 times 6x is 24x, 4 times 7 is 28, and we got minus in between. Over here, 5 times negative 2x is negative 10x, 5 times 12 is 60. Okay, from here, I am going to make subtraction become adding the opposite, and then I'm going to switch the order, get my like terms together, gives me 29x. Over here, the constants give me negative 10. Oh, that's not simplest form. Make that 29x minus 10. Over here, commutative property to get my like terms next to each other, and then negative 10x and 8x is negative 2x, 60 and 14 is 74. If you need to hit pause, fix whatever work you got to fix, feel free to do that. Part B, which triangle has a greater perimeter if x equals 2? Will this still be true if x equals 3? Justify your responses by showing your work. So we're going to take the perimeters that we just had from part A, and we're going to substitute, starting with the 2, if x equals 2. And then we're going to do it again with when x equals 3. Now, if you already realize you didn't do this right, hit pause now, fix what you got to fix, and then hit play once you're done. All right, over here. 29 times 2 is 58. 58 minus 10, 48. Negative 2 times 2 is negative 4. Negative 4 plus 74, subtract in your head, you get 70. On that one, triangle 2 had the bigger perimeter. But will that still be true when x is 3? Let's find out. 29 times 3 is going to give me 87. Minus 10 is 77. Negative 2 times 3 is negative 6. Subtract in your head from the 74, and you will get 68. Oh, on that one, triangle 1 had the greater perimeter. So it depends. Triangle 2 had the bigger perimeter when x was 2. We can see the work here proving that. But triangle 1 had the bigger perimeter when x was equal to 3. So there's your answer for part B. All right, thanks for watching this video. We'll see you next time.